this gets to the question that I asked on the what do you know, which is what do you know about measuring an atom? And you guys all talked about mass, because that's the only measurement of atoms that we have talked about thus far. We've talked about AMUs, measuring the mass of atoms. Now we're going to start to talk about actually measuring them spatially. So, you know what the radius of a circle is? What's the radius of a circle? Half the diameter, yeah, half the distance across the circle. So we talk about atomic radii. And atomic radii, we measure, now this is interesting, only when we have two bonded atoms. Huh, that's weird. So if we took two identical atoms, we bonded them together, so I'm going to do that right here. And we know that like fluorine is diatomic, so these could be fluorines. And the little F stands for the nucleus of the atom. If we take the entire distance between those two nuclei, and then we measure half of it, that's an atomic radii. So it's half the distance between the nuclei of two identical atoms that are bonded together. Let me move my little illustration up here. Okay, well that's easy enough, but here's the weird thing. There are actual trends in atomic radius. So if you look at a periodic table, if you start at group 1 and you head towards group 18, so look at your periodic table, look at group 1, and let's look at like period 4, okay? Because we can go all the way across period 4. So what starts us off in period 4? Stick your finger on it. Period 4, group 1. Potassium. Okay? Get it? Potassium, K. Yeah, I know. Okay, if you go right straight along period 4, as you move towards group 18, what is happening? Are you adding or subtracting stuff? You're adding stuff. You're getting, every time you move over, you're getting one more proton and one more electron. What usually happens to things when you add stuff? They get bigger! And yet I am telling you completely counterintuitively that when you add stuff, the atomic radii gets smaller. Why? What possible explanation could you come up with for this malarkey? Okay, give it a shot. What table thinks they have a likely explanation for this? Anybody, anybody? It's a mystery. No one knows. No possible explanation. What explanations could you think of? Come up with something. I don't care how crazy it is. So, okay, we got one crazy idea already. As you add more stuff to the nucleus gets bigger. It gets closer to the outside of the electron cloud. Maybe I should have let you keep going with that a little bit, Matt. Other crazy ideas. Okay, so far, here's what we've got. You know, if I put the two of you together and I smooshed your ideas together, we might be onto something. So how many valence electrons do we have in group 1? Oh, I just wrote it up there. 1. How many valence electrons do we have in group 2? 2. How many valence electrons will skip over to group 13? Do we have in group 13? 3. How many valence electrons do we have in group 14? 4. How many valence electrons do we have in group 15? 5. How many valence electrons do we have in group 16? 6. 7, 8. Okay. So is what Kobe is saying, yes, Kobe. Is what Kobe is saying true, that as we go from group 1 to group 18, we have more valence electrons? Yeah, it is. And you're saying because you have more of them, they pull in closer?
Yeah.
What do they pull on? Talk to Matthew. one. The nucleus, yes. Yes. So actually, if we smushed your idea together with your idea, you've got it. I should have let you expand on that, because I bet you could have. As you go from group 1 to group 18, let's draw this. I guess we'll pick that up tomorrow. Have a good night, folks.